Today I'm going to show you an easy way to factor quadratics. We'll start with this example, x squared plus x minus 2. The coefficient of x squared is 1, and there's only one way to factor that, 1 times 1. The constant term is negative 2, but you can ignore the negative sign. Just look at the 2 and factor that. 2 only factors one way, and 1 times 2. Notice how I line the numbers up. We'll draw a line like this, then we'll cross multiply. 1 times 2 is 2. Then in the other direction we get 1 times 1, and that's a 1. We're going to adjust the bottom numbers so they add up to the middle coefficient, the coefficient of x. In this case it is positive 1. Obviously it's positive 2 and a negative 1. We're going to put a plus sign in front of that 2 to show where the positive 2 comes from. We'll put a negative sign in front of the 1 to show where the negative 1 comes from. Before we solve the problem, we have to double check the constant term. The negative and the positive do produce a negative 2, so we're all set. If that constant were positive 2, then we cannot solve this problem. Now we can read the two factors off. They are x minus 1 and x plus 2. In example 2, we'll factor x squared minus 5x minus 6. The coefficient of x squared is 1. That factors one way into 1 times 1. The constant term 6 factors two ways into either 1 times 6 or 2 times 3. So in this problem we have choices, either the 1 and 6 or the 2 and 3. We might as well start with the first column, 1 and 6. Let's cross multiply. 1 times 6 is 6. The other way, 1 times 1 is 1. Next we'll see whether we could adjust the signs of the 1 and the 6 so that they add up to negative 5. And indeed we can. We could use a positive 1 and a negative 6. So let's put a plus sign in front of the 1 and a negative sign in front of the 6. Next, double check to make sure the constant is indeed negative, and it is. So now we can go ahead and read off the two factors. They are x plus 1 and x minus 6. The next example is x squared minus 5x plus 6. I tricked you, didn't I? This should look very familiar. So there you go. It's the same chart as before. but we're going to use the second column this time. We cross multiply. 1 times 3 is 3. The other direction we get 2. Now we adjust the signs on the bottom to see whether we could obtain a negative 5. And yes, we can. So it's going to work. Put a negative sign next to the 2 and a negative sign next to the 3. Multiply the negative 2 and negative 3 together, we do get a positive 6. That tells you why in the last problem, if we had chosen this, it would come out wrong. Remember, you could always check your answers by multiplying the factors back together again. This one looks a lot more interesting, doesn't it? 10x squared minus 57x plus 11. 10 is the coefficient of x squared, and that factors into 1 times 10 or 2 times 5. And look at 11. That only factors into 1 times 11. Turn it upside down, or else we won't get all the possible combinations. You might be able to stare at that for a little while and pick out the correct 2 columns to use. I see it, do you? We have a negative 55 and a negative 2. Negative signs in front of the 11 and 1. Those do multiply together to produce a positive 11. It worked. We can read off the 2 factors. They are 2x minus 11 and 5x minus 1. Here's example 5. 3x squared minus 17x minus 6. The 3 factors into 1 times 3. The 6 factors in 2 ways. 1 and 6, 2 and 3. But to cover all the choices, we have to turn those upside down, so we have 4 columns on the right side. Now look at the middle coefficient. It's 17. Do you see that anywhere? I see it. Do you see it? If you don't see it, just keep cross-multiplying. It's trial and error. But if you see it, it becomes pretty obvious. It's the column 6 and 1. If you're using a pencil and eraser, it's not a good idea to erase, because if you made a mistake, then you have to start all over again. So it's better just to copy those 2 columns, 1 and 3, 6 and 1 down in a separate chart and try that out. And if it's wrong, then you could choose some other column. So cross multiply, 1 times 1 you get 1, 6 times 3 you get 18. We can use a negative 18 and a positive 1. Make that a negative 6. And a positive 1. When you multiply those 2 numbers together, it does come out negative for the constant terms, so we're in good shape. Now we can read off the 2 factors. X minus 6 times 3x plus 1. Once again, multiply those out to make sure you did the problem right. Look at this example. 8x squared plus 54x minus 14. Those numbers are so large. The first thing we should do is divide every coefficient by 2. And the resulting equation is 4x squared plus 27x minus 7. So that simplifies the problem quite a bit. Now let's factor the x squared coefficient, the 4. It factors into 1 times 4 or 2 times 2, whereas 7 only factors one way, into 1 times 7. Once again, to cover all the bases, make sure you flip that over. You'll have a column of 7 and 1. So now, the middle coefficient is 27. Do you see it? 27. You see, I'm just checking different combos, and I think I see it. Do you? Yes, it's those two columns, 1 and 4, 7 and 1. So let's separate those into a different table. 1 and 4, 7 and 1. Cross multiply. 1 times 1, you get 1. 4 times 7 is 28. Perfect. That makes it positive 28 minus 1. So the 7 has a plus sign in front. The 1 has a negative sign in front. The constant term is a negative 7, so that is correct. And we could read off the two factors. They are x plus 7 times 4x minus 1. So the original quadratic factors into 2 times x plus 7 times 4x minus 1. Example 7 is negative 4x squared minus 17x plus 15. I don't like the negative sign sitting in front of the 4. So the first thing I'm going to do is factor out a negative 1 and work with the quadratic positive 4x squared plus 17x minus 15. The 4 factors into 1 times 4 and a 2 times 2, and the 15 factors into 1 times 15 and 3 times 5. Once again, make sure to flip those over so we cover all the possibilities. Now we're going to look at all those and try to get a 17 in the middle. Do you notice something about the 2 and 2? They're even numbers. And when you multiply an even number by any number, it comes out even. And when you add even numbers, they come out even. You can immediately rule out that column 2 and 2. It has to be 1 and 4. So now look, take the 1 and 4 and cross multiply with the columns on the other side to see what happens. The 15s aren't going to work out, are they? So the next one we see is the 3 and the 5. So let's check that column out, the 3 and the 5 and the 1 and the 4. Cross multiply those. We get a 5 and a 12. So it seems to work. Make them both positive, and look what happens. Uh-oh, it didn't work. The constant term is a negative, so that's wrong. We wasted our time there. I guess it's the 5 and 3 instead, right? So let's check that out. The 1, 4 and the 5, 3. 1 times 3 is 3. 5 times 4 is 20. We can get a 17 out of that, can't we? Positive 17. We need a plus 20 and a minus 3. And that's going to work. Put a plus sign in front of the 5, a minus sign in front of the 3. Those multiply together and give us a negative 15, so it's perfect. The original quadratic is therefore equal to negative, because we factored out a negative 1 in the beginning. A negative times the 2 factors, x plus 5 and 4x minus 3. And here's the last example. 12x squared minus 35x plus 18. I doubt that you need to factor anything more difficult than this one. So let's give this a try. The reason this problem's a mess is because there's so many possible combinations. The 12 factors into 1 times 12, 2 times 6, and 3 times 4. Whereas the 18 also has many factors. 1 times 18, 2 times 9, 3 times 6. Then we have to turn all those upside down, so there's 6 possible combinations. However, we can save ourselves some work if you notice that 2 and 6 are both even numbers. Multiplying any number by an even number results in an even number. Adding them also results in an even number. And since the middle coefficient is odd, we don't have to bother with that 2, 6. I usually leave the large numbers alone unless I have to. So I'm going to try out the small numbers first. I'll use the 3, 4 on the left side. And I think I'll start on the right side, the far end, the 6, 3. Then gradually move towards the left. And sooner or later we're going to get it. There it is, 27 and 8. See it? 27 and 8 add up to 35, so that's going to do it. Let's make a different table with the 3 and the 4, the 2 and the 9. Cross multiply, we'll get 27 and an 8. Make both of those negative, so they add up to negative 35. That means we have a negative 2 and a negative 9. Which multiply to positive 18, so it's right. And we're done. The answer is 3x minus 2 times 4x minus 9.